All right, here is the answer key to practice 8C. We're not going to worry about number 1. I mean, they're right over there, so I'm not going to spend a lot of time rewriting these because they're literally, all you have to do is scroll over. What I will say is some people say single displacement, some people say single replacement. It works the same way. So if I said double displacement or if I said double replacement, it means the same thing. And finally, lighting stuff on fire. All right, here we go. Classify each of the following reactions as synthesis, decomposition, single displacement, double displacement, or combustion reaction. We've got these formats that tell us a synthesis reaction is A plus B yields AB, taking two elements and making a single compound. A decomposition reaction is taking a compound and breaking it up into two elements. They don't have to be elements. They could be less complicated compounds or elements. A single displacement is taking one element, combining it with a compound, and on the other side we get the original element now in the compound, booting out a second different element. Double displacement reaction involves complete switching A, X, and BY. The B shacks up with the X and the A shacks up with the Y. And finally, a combustion reaction always has the same products, CO2 and H2O. So here we go. Obviously, we have a reaction that is taking two elements and combining them into something that is all by itself. Obviously, that's a single I'm sorry, I apologize. That's a synthesis reaction. It fits the format. Here looks a little weird, but we have a single element on one side, on the reactant side, a single element on the other side, and of course, two compounds. Ladies and gentlemen, there's really only one reaction that this could possibly be, that being A and that being BX. Of course, that means AX and B. That means that the B is the hydrogen and the X is, of course, the OH. And if we were to write this out a little differently, it would look like this. We would say 2 lithiums plus 2 HOH. That's our water. What happens is we're treating these two as our B and our X. And so when we put this together, we get lithium and OH and H2. And we'll balance it so it looks like this. Okay? So don't have to freak out too much. That's a pretty obvious answer. There's only one reaction this one could possibly be. That is a single replacement or a single displacement. Okay? Here is pretty obvious. We've got one compound on the reactant side and two on the product side. There's really only one reaction that this could possibly be. Remember that we're treating this as a single compound, AB, and obviously the A is NaNO2 and the B is the oxygen. Don't panic. We're just looking for something that breaks up from one reactant into two products. We're going to call that decomposition. Here, it's pretty obvious that what's going on is we're reacting something with oxygen and the products are carbon dioxide and water. Over here, we see that our combustion reaction means we're reacting something with carbon and hydrogen, sometimes oxygen, with oxygen to produce always carbon dioxide and water. There's only one reaction that could possibly be, and of course that means that's a combustion reaction. All right, now that we know what they look like, let's do it. However you want to interpret this is up to you. Obviously this is telling us that this is a synthesis reaction, and so that means A plus B is going to give us AB. Clearly the A is lithium. Clearly the B is oxygen. If you wanted to balance this, this would work. I would accept this, but the true answer is that oxygen usually exists as O2, and so we're going to need 4 lithiums for that. But however you want to do it, as long as it looks good and is balanced. Here is a decomposition reaction. It's where AB turns into A and B. Obviously the A is the magnesium and the B is clearly Cl. You could either write it as 2Cl or you could write it as Cl2, and that would work too. All right, here is a double displacement reaction. Right off the bat, we know we're looking for AX and BY. Clearly the A is the hydrogen, the X is this nitrate, the B is the calcium, the Y is hydroxide. When I put them together, it doesn't really matter what order, but we know we're going to get AY and BX. There's our AH, there's our YOH, there's our BCA, and there's our XNO3. Okay? So if you want to write this correctly and you want it to balance, okay, so the way that we're going to do this is we're going to say H2O is one of our products, CaNO3 is another one of our products, and we want to balance this. So because there's a 2 in front of this nitrate, I'm going to put a 2 here. That makes 2 hydrogens, and there's another 2 here, but we also want to take care of the oxygen, so putting a 2 in front of that water takes care of that. All right? So let's do this last one in number 3. It's clearly a combustion reaction. Let's remember that in a combustion reaction, you're always combining a carbohydrate with oxygen, and the products are always CO2 and water, so that takes care of that. Let's balance this by putting a 5 next to this carbon. Let's put a 6 next to this hydrogen, and that means that on this side we have 10 plus 6 is 16 oxygens. I'll put an 8 there. All right, we're almost done. For each of the following reactions, identify by type and write in the missing products and then balance. All right, I'm going to take you back to Lab 5B for this one. Let's go there. I'm going to go to Chapter 5, and we're looking at Lab 5B. We want the actual body of the lab. I apologize. And so we remember that when we did this, we had 3 equations that we were trying to test. If you'll recall, we had reacting chlorine with sodium fluoride, chlorine with sodium bromide, and chlorine with sodium iodide. And remember that this one didn't do anything, but these 2 did. We got sodium chloride and bromine, and we got sodium chloride and iodine. Notice that the chlorine isn't replacing the sodium, ladies and gentlemen. This is a halogen from group 17. These are halogens from group 17. We're not worried about the chlorine replacing the sodium. We're worried about whether or not it can replace the other halogens, right? So let's go back here. And what we're worried about is the exact same thing. Can this bromine replace the iodine? We're not worried about can it replace the potassium. That means this is going to look a little different. We'll call that our A, we'll call that our B, and that's our X. That means our products should be B and XA. Well, that means the B is going to be iodine, X is the potassium, bromine is the A. That's our clearly a single displacement reaction. There's really no other reaction this could possibly be. And so we'll say, because it looks like what we did in Lab 5A, that this is single displacement. And we'll balance it because it asked us to balance it. See that 2? Put a 2 there, put a 2 there, put a 2 there. All right. Here we go. Obviously, we have 1 compound and the reactant side, and clearly 2 products, 2 items on the product side. There's only one thing this can be. It has to be decomposition. And you could write this a couple ways. You could just say NaCl. You really wanted to impress me. Cl always looks like that, and we're going to need to balance it, and that looks like this. All right. Obviously, we're reacting a carbohydrate with oxygen. That means this has to be a combustion reaction. There's nothing else it can be. That means our products are always CO2 and H2O. I'm going to balance this by putting a 7 in front of the carbon. I'll put an 8 in front of the hydrogens. That means we have 14 plus 8 is 22 oxygens. I'll put an 11 here. All right, the last one, clearly that's an AX, that's a BY. This has to be a double displacement reaction. And what are we going to do? We'll have BX and AY as our products. That's our B, that's our X, so NaCl is one product. That's our A, that's our Y, so CuS is another product. I'm going to balance it by putting a 2 here. Okay, that's all you do. See you tomorrow. Good luck on the quiz.